x is equal to 3 cos t and y is equal to 9 sin 2t. 9 sin 2t can be written as 2 sin t cos t. So y can be written as, this can be written as 6 sin t and 3 cos t. So y is equal to 6 sin t, 3 cos t is x. So y is equal to 6 sin t can be written as 1 minus cos square t. So that is 6x 1 minus cos square t is x square over 9. So y is equal to, this is the complete root, so y is equal to 6 over 3 x root, this is 9 minus x square. Now if is meet the x at the origin and at point A and B as shown, find the coordinate of A and B. So we can say that at A and B x is 0, so y will be 6 over 3, that is 2, multiply 0, root 9 minus 0 square, that is root 9. So y is equal to plus minus 3 and x is already 0, so the point, so coordinate of A will be minus 3, 0, and the coordinate of B will be 3 and 0. This was part A. Now part B is find the value of t which the curve passes through the origin. So we have x is equal to 3 cos t. So at x is equal to 0, so t is equal to cos inverse 0. So cos inverse 0 is this and this. So that is pi over 2 and 3 pi over 2. We have to find dy over dx. That is dy over dt divided by dx over dt to get dy over dx. Over x is 3 cos t. First we find the sine. That is 9 sin 2t is cos 2t multiplied 2. Dx over dt, x is cos t, so 3 minus sin t. So that is 18 cos 2t over minus 3 sin t. So that is minus 6 cos 2t over sin t. So that can be written as minus 6 cos 2 pi over 6 over sin pi over 6. So that is equal to minus 6. That is the answer of part C. Part D. Show that the Cartesian equation of the curve C can be written in the form of, it can be written as y square is equal to ax square b minus x square. We have to prove this. Y square can be written as 18 square sin square t cos square t. Now cos t is equal to x over 3. So cos square t is equal to x square over 9. Sin square t is equal to root 1 minus x square over 9. There will be no root because we are looking for the square value, not the root value. So we are looking for sin square. So we put these values here. So y square is equal to 18 square sin square t is 1 minus x square over 9 and cos square is x square over 9. So y square is equal to 18 square. This is 9 minus x square multiply x square divided by 9 and 9. So y square is 18 times 18, so 2 times 2, that is 4 x square 9 minus x square. So if we compare with this equation, y square is equal to ax square b minus x square. So a is equal to 4 and b is equal to 9. So that is the proof of this. Question number 12. Express 2 sin x minus 4 cos x in the form of r sin x minus alpha, where r is greater than 0 and alpha is between 0 and pi over 2. We compare it with r cos alpha sin x minus r sin alpha cos x. So r cos alpha is 2. So we can write r cos alpha is equal to 2 and r sin alpha is equal to 4. If we square both sides, then r square will be common sin square alpha plus cos square alpha. So this will be, it will be 1. So this is 2 square plus 4 square. So r square will be 16 plus 4 root 20. R will be root 20. Find the exact value of r. So exact value of r is 20. the value of 10 alpha. R sin alpha is equal to 4 divided by R cos alpha is 2. So R cancel. 10 alpha is equal to half. Alpha is equal to 10 inverse half. So that is 1.11. So this is the value of alpha in a radian. Alpha is equal to 1.11. Now, given that in a town of Norway, a student records the number of hours of a daylight every day for a year. He models the number of hours of daylight h by the continuous function given by the formula h is equal to 12 plus 4 sine 2 pi t over 365 minus 8 cos 2 pi t over 365. Let me write this formula here that says that 2 sine x minus 4 cos x is equal to r sine x minus alpha. So in this question, if we take 2 common, let's take this part only. 2 sine 2 pi t over 365 minus 4 cos 2 pi t over 365 this value must be equal to 2r sine x is 2 pi t over 365 minus alpha. So our equation is h is equal to 12 plus, this is 4 sine 2 pi t over this, so it can be written as, so h is equal to 12 plus 2r sine 2 pi t over 365 minus alpha. So we have reduced the equation to this. Now for the maximum and minimum number of hours, so we can write h is equal to 12 plus 2r, that is for maximum, and h is equal to 12 minus 2r, that is for minimum. So h will be 20.9 hours and h will be 3.06 hours. So that is the maximum and minimum numbers of hours for the daylight. This was part B. Now part C. Use the formula to find the value of t when h is equal to 17. So we can write this formula: h is equal to 17 is equal to 12 plus, this is 2r, so let's write kr sine 2 pi t over 365 plus minus alpha. So that is, in fact we can replace this k by 2. So if we solve it, we'll find that t is equal to 99 or t is equal to 212 days. This figure shows the sketch of part of a curve C with equation y is equal to 1 over 2 ln 2x, x is greater than half. The finite region R showed shadow in figure 4 is bound by the curve C. X-axis, x is equal to e and x is equal to 5e. The table below shows the corresponding value of x and y. Y is equal to 1 over 2x ln 2x. The values of y are given to 4 significant figures. Use trapezium rule with all y values in the table to find the approximate value of the area of R, giving your answer to 3 significant figure. Now integral a to b y dx is equal to half h multiply a plus 2 b plus c and so on plus the last value. So we can write half h is e or e minus 2e or 2e minus e is equal to e. So h is e. This one is 3.114. Last one is 1.215. 1215 plus we add this values and multiply it by 2. So we can write it as 2 multiply 0.2195 plus 0.1712 plus 0.1416 and complete bracket. So the area will be, if you calculate, that will be up to 4 the finite region A, up to 3 significant figures. So that is 2.04. So that is the area of region R. So part D is part C. Use your answer to part B and find the true area of R. So integral e to 5e y dx is equal to 1 over 4 ln 2x square e to 5e, and that is equal to 2.01. So that is the area of, that's the actual area. Part D. Using calculus, find an equation for the tangent to the curve at point where x is equal to equation of tangent at x is equal to e square over 2, and give your answer in the form of y is equal to mx plus c. Now to find the equation of tangent, we need dy over dx of half one over x you know that y is equal to 1 over 2x ln 2x. First function 1 over x into differential of second 1 over 2x into 2 minus ln 2x into differential of 1 over x. So that is 1 over 2x square x to the power minus 1. So this is equal to 1 over 2x square minus ln 2x over 2x square. So when x is e square over 2, so dy over dx is 1 over 2 e square over 2 square minus ln 2 e square over 2 over 2 e square over 2 the square. So dy over dx will be, that is 1 over 2 e to the power 4 over 4 minus ln 2 e square over 2 over 2 e square 4 over 4. So dy over dx will be, this is 2 over e to the power 4 minus this 2 and 2 cancel, this 2 will come here, ln e will cancel automatically, this will cancel by 2, this 2 will go up there, and this will be e to the power 4. So that is 1 over e to the power 4 common, 2 minus 4. So dy over dx will be minus 2 over e to the power 4. That is a one thing. Now we have got dy over dx. To find the equation of tangent, we need this. Now we have to find the points. So x is given e square over 2. So y is equal to 1 over 2x ln 2x. So if put x is equal to e square, so 1 over 2 e square over 2 minus ln 2 e square over 2. This 2 and 2 cancel, so y will be 1 over e square minus this 2 will cancel and this 2 will come here, ln e will become 1. So minus, so this will be, so this will become, this 2 will come here, so this will be multiplied by 2. So the y will be 2 over e square. Now we can write the equation y minus y1 . So y minus y1 is equal to dy over dx x minus x1. So y minus y1 is 2 over e square is equal to dy over dx minus 2 over e to the power 4 x minus x1 is e square over 2. So y is equal to, let's multiply this, minus 2 over e to the power 4x minus minus plus 2e square over 2 2e square over 2 and 1 over e to the power 4, then minus, this will become plus 2 over e square. So y is equal to minus 2 over e to the power 4 plus this cancel by e square, 2 and 2 cancel, 1 over e square plus 2 over e square. So y is equal to minus 2 over e to the power 4 plus this is 3 over e square. So I don't think we can further simplify it. So this is the equation of tangent passing through e square over 2. Next question is, the volume of a spherical balloon of the radius r centimeter v is equal to 4 over 3 pi r cube. So dv over dr is 4 over 3 pi, that is a constant. R cube is 3r square. So that is 4 pi r square. That is dv over dr. That is the first part. Part A. Now part B is, the volume of a balloon increases with the time t seconds according to the formula dv over dt. Using the chain rule or otherwise, show that dr over dt. So we have dv over dr, dv over dt, dr over dt. We have to prove dr over dt. So part B we have to prove dr over dt. So that is dr over dv over dt over dv. Is equal to, this is dv over dr, so this is 1 over 4 pi r square, and this is dt over dv, so this will be t plus 81 5 over 4 over 9000 pi. So that is equal to 9000 pi divided by 4 pi r square t plus 81 5 over 4. So that is, we cancel pi by pi. 9000 divided by 4 is 2250 over r square t plus 81 5 over 4. So dr over dt will be, this is a constant, this is also a constant, t plus 81 5 over 4. So that is what we are supposed to prove in this question. dr over dt is, using the value of k and n found in the part B, solve the differential equation in terms of r and t. So we have dr over dt, and this is r to the power n. Let's write the differential equation, that is dr over dt is equal to k over r to the power n t plus 81 to the power 5 over 4. So this equation can be written as r to the power n dr is equal to k over t plus 81 5 over 4 dt. So r to the power n plus 1 over n plus 1 is equal to k t plus 81 is to the power minus 5 over 4 plus 1 minus 1 over 4, so minus 4 plus c. Now r is equal to 3 and k is equal to 2250. R to the power 4 over 4. I was not 4, I was 2. So that is r cube over 3 is equal to minus k is 2250 multiply 4 t plus 81 is to the power minus 1 over 4 plus c. So r is equal to, this is minus 9000 t plus 81 minus 1 over 4 plus c. The question says initially when r was 3. So 3 cube is equal to minus 9000. T is equal to 0. 81 is to the power minus 1 over 4 plus c. So c will be the r will be 3009 minus 9000 t plus 81 is to the power minus 1 over 4 cube root. That is not r cube, that is r is equal to. So that is the value of r. Now we move to part D. Part D says, hence find the radius of the balloon when t is equal to 175. So when t is equal to 175, so r will be cube root, this is a cube root, 3009 minus 9000 175 plus 81 is to the power minus 1 over 4. So the cube root of all this. So if you calculate, the value of r will be 13.2. When t is equal to 175, r is 132. Part E will be find the rate of increase of the radius of the balloon when t is equal to 175. Give your answer to 3 significant figure. Rate of increase of the radius of balloon, that is dr over dt. So dr over dt is that is 2250 over r square. T is 175 plus 81 is to the power 5 over 4. So if you calculate, that is equal to 0.0126 up to 3 significant figure. So these are the 3 significant figures. So that is the answer, 126. So that's the end of Core Mathematics 34, January 16, 28. I've tried my level best to explain each and every step, but if you find any of the step you are not understanding, just text me and I'll explain it in a different way. Thank you very much and keep watching Maths Rag, and don't forget to subscribe me.